Hello, now we're going to do this integral. And this integral, if you can see, it has a quadratic in the radical. So it looks like it could be an a squared plus or minus u squared situation, which is an arc trig function or maybe an inverse hyperbolic function. Uh, so nothing else works that I can see. So let's try to get this into a u squared minus a squared or vice versa. So to do that, this quadratic in the radical, we're going to complete the square. So this is complete the square. This is one of the more complicated ones, but it's still not that hard. So I'm going to write the quadratic function. I'm going to save this minus 1 and complete the square on these first two terms. So the first thing we're going to have to do is factor out -4. And it's useful to keep the 1 completely separated here because now you don't have to worry about it. But if you're going to do that, make sure you understand that it only applies to those first two terms. So use your parentheses. Completing the square on this 2, you're going to add b over 2 quantity squared. So 2 divided by 2 is 1 squared. 1 squared is 1. So you're going to add and subtract 1. Make sure you do all of this inside the parentheses. So I'm going to add 1, subtract 1. You can see the reason why it's so important to do it within the parentheses is that -4 is going to be applied to it. So by virtue of completing the square, the x squared minus 2x plus 1 is a perfect square trinomial, and it factors into x minus 1 quantity squared. And now I'm going to distribute the 4. And there we go. So my integral, which I'm going to rewrite over here, is really 1 over x minus 1. That looks good because you see this x minus 1 over here. That's a match. And the square root of 4 minus 1 is 3, minus 4 times x minus 1 quantity squared. So that looks like my u is going to be, take care of the 4 times x minus 1 squared, and 3 is going to be the a squared. So I think we're ready to go. This looks like it will be one of those arc functions. So let's take care of the u substitutions first and see what happens. So this is u squared. So I need to figure out what u is. You're going to take the square root. That would just be 2 times x minus 1. And as everybody knows, du must be calculated. It's going to matter. So the derivative of 2x minus 2 is 2. And remember, a in this case, just as a reminder, would be, since this has to be a squared, where the 3 is, a would be the square root of 3. So here's all my u subs. I have, in the square root, I have root 3 squared minus u squared. My dx is equal to 1/2 times du. And this x minus 1 is, well, look at it. It's right here. X minus 1 is actually u over 2. So let's change the x minus 1 that was here to just u over 2. So that whole thing's divided by 2. So you multiply by the reciprocal. That's going to be 2 over 2 on the outside. So just simplifying a little bit, this is going to be 1 times the integral of du over u times the square root of a squared minus u squared. So that's either, from my memory, going to be like an arcsecant or maybe one of those hyperbolic inverse And I cheat a little bit. I know what it's going to be. Looking at all my formulas, well, this formula gives us exactly what we need. Du over u times the square root of a squared minus u squared. So this is actually from an arc hyperbolic function. So I'm going to use this formula. So this integral would be exactly equal to negative 1 over a, negative 1 over root 3 times the natural log of a plus the square of a squared plus u squared, which was what we started with before we completed the square. So you can keep it as a squared plus u squared. I'm going to change it to negative 4x squared because that's what we started with. Negative 4x squared plus 8x minus 1. And then that's all over the absolute value of u, which was the absolute value of 2 times x minus 1 plus c. And that's it. So it's an interesting integral. It's not that complicated if you understand completing the square and have those formulas in front of you. So that is all.